Recognizing prime and composite numbers. Well, what is a prime number? A prime number is a number that only has two factors, 1 and itself. What that means is there's only two numbers that will divide into it evenly. For example, 17, there's only two numbers that will divide evenly into 17, 1 and 17. Now, composite numbers have more than two factors. For example, 40 has lots of numbers that will divide evenly into it. 1 will go into 40, 2 will go in, 4, 5, 8. It has lots of factors that will divide into it evenly. And if a number has more than 2, which this has a lot more than 2, it's a composite number. Now, a couple of things just to remember. 0 and 1, they're not prime numbers or composite. They're neither. And the number 2 is a special number because the number 2 is the only even prime number. There are no other even numbers that are prime except for 2. So, how do I identify a prime or a composite number? Well, you can use your divisibility rules to help you determine primes and composite numbers. I'm just going to go ahead and reveal these divisibility rules for 2, 3, 4, 5, 6, 9, 10. And you can pause this and look at them if you want. But we're going to use these in the next examples to determine whether these numbers are prime or composite. So let's go ahead and do a few. Now 280, that's an easy one to tell if it's prime or composite. You look at the last digit, it's a 0, which means this is an even number. And because it's an even number, we know that 2 will go into it. And if 2 goes into it, then it is a composite number. Remember, if any other numbers other than 1 and that number will go into it, it's a composite number. Let's look at 85. Now, using your divisibility rules, it's an odd number, so 2 won't go into it, but it does end in a 5. And if it ends in 5, that means it's divisible by 5. And if it's divisible by 5, that means 5 goes into it, it's a composite number. Now, when you look at the next example, 471, it looks like it might be a prime number. It ends in 1. It's an odd number. But if you remember the rule for 3, if we add up the sum of the digits, 4 plus 7 plus 1, 4 plus 7 plus 1 is 12. The sum is 12. And the divisibility rule for 3 is, if 3 will go into the sum of these numbers, 3 goes into 12. So this whole number is divisible by 3. And since it's divisible by 3, it's a composite number. 261. Again, it looks like it could be a prime number. But if we add up the digits, 2 plus 6 plus 1, we get 9. And the divisibility rule for 9 is if you add up the digits, and 9 will go into the sum, which it will here, then this whole number is divisible by 9. Actually, 3 would go into that as well. So this is definitely a composite number. The next one's easy. All you need to do is look at that last digit. It's an even number. And remember, 2 is the only even number that is prime. So since 2 goes into this, it has more than 2 factors. It's a composite number. 19. Well, 19 is an odd number. 2 won't go into it. Add up the digits, you get 10, so 3 won't go into it. 5 doesn't go into it. 6 won't go into it. 9, 10, 9 won't go into it. It looks like the only numbers that will go into 19 are 1 and 19. Therefore, it is a prime number. So that's how you can use your divisibility rules to help you determine whether or not a number is prime or composite.